Hello, everyone. Thanks for joining today. We're going to pause for just a moment while everyone logs in. If you've just joined, this is the Fluke presentation. Thank you for coming today. We'll get started in just a moment. All right, hello, and thanks for joining. This is Leah Freeberg from Fluke Reliability. We appreciate you joining us for this best practices webinar today. You probably know Fluke is a test tool provider, and you may also know that we produce some of the industry's favorite reliability tools, from infrared cameras to vibration meters. But you may not know that many of the measurements that our tools collect now flow automatically into the EAM systems of record. It happens via a framework that we call Fluke Connect. Our goal at Fluke Reliability is to better connect asset management data and teams with asset management systems to drive connected knowledge. And of course, that knowledge depends greatly on best practices in condition-based maintenance. So that's why this series of webinars explores reliability maintenance strategies, and that's why we feature speakers from a variety of expert backgrounds. Before the presentation, I have a couple of housekeeping items to go over. Today's session is being recorded, so the phone lines will be muted to minimize background noise. We will save time after the presentation for your questions. If questions come up during the presentation, you are welcome to use the questions feature on GoToWebinar to submit comments as we go. So take a minute now, find the questions tool in the dashboard. At the end of the talk, I will share as many of your questions as time allows for our presenter to answer. If we have unanswered questions, we'll follow up with written answers. If you'd like to receive the slides from today's presentation, please let us know during the survey that appears at the end of today's session. Don't hang up until the survey appears and you've answered the questions. A recording of this webinar will be available on the Excelix.com webinar within a day or two. And that's it for housekeeping. So now for the main event. Today, we are very pleased to have with us veteran machinist and millwright Dave Metz from PRÜFTECHNIK. He'll be presenting on tips, technology, and tools for next-generation machinery alignment. Dave is a technical sales representative for PRÜFTECHNIK, covering the state of New York. Previously, he served as a machinist and millwright with more than 30 years of technical craft experience with excellent energy. Dave has an extensive background performing machinery alignment on rotating equipment, from the very small to the largest GE steam turbines and generators. He is also proficient at vibration analysis with Category 2 certification from Mobius. Welcome, Dave, and thank you very much for being with us today.
Thanks, Leah. It's nice to be here today. Thank you very much.
I have a quick question for you, Dave. Based on the title of today's presentation, I had always considered alignment to be a more advanced practice, but it sounds like with the changing workforce that we need to make alignment more accessible to a broader group of industry professionals.
Yeah, it's definitely true. The tooling it used to take took a long time to learn, so it typically was a job for somebody with a lot of experience in just alignment. But nowadays, the tools that we use are very good, really easy to interface with and easy to learn, and in a lot less time you can become really proficient at alignment.
Okay, all right. Well, why don't you tell us a little bit more about PRÜFTECHNIK?
PRÜFTECHNIK's was founded in 1972 as a small family-owned company, and we are the innovators of laser alignment, shaft alignment, and probably have the largest market share in laser alignment tools. And I was using their tools for many years and really loved them, and that's why I left the company to come work for them. The North America team is based out of Philadelphia, and we are represented all over the world with PRÜFTECHNIK locations all over. So, but we also do condition monitoring, non-destructive testing. We're into a lot of other things, and now we're with Fluke Reliability, and it seems to be going pretty well.
I did not know that PRÜFTECHNIK started laser alignment. That is a great one to have.
Yeah, basically they were the leaders for sure for many years. Yeah, we're definitely still the leaders in laser alignment. Yeah.
Okay, all right. Well, I think we're going to get started with the poll. If you want to forward to the next slide, I'm going to give the audience a chance to weigh in before the main presentation. So for the benefit of Dave and everybody else, we're going to ask you all this question, and it's going to appear on your screens. So use your mouse to select the answer that best reflects. Are you currently using a laser shaft alignment system? And you'd only get one choice. So yes, I am currently using a laser shaft alignment system. I'm using an older laser shaft alignment system, or I'm using a dial indicator, I'm using a straight edge or feeler gauge, or I'm not using a system or tools for alignment. So any answer is fine. And I'm hopeful that we can get about 75% of the audience to vote. If you can't select the buttons, you may need to reduce it from full screen. Sometimes that can interfere in the ability to select the poll answers. So I'm going to give it just another couple of seconds. I know there's a lot on the screen here, but basically tell us what kind of alignment system are you using right now? Is it laser? Is it a dial indicator, straight edge, feeler gauge, or you're not doing much right now? Okay, we have about 70% in, so I'm going to share the results with everyone right now. So Dave, we have 33% who are using a current laser shaft alignment system, 11% are using an older one, 16% are using a dial indicator, 8% are using a straight edge or feeler gauge, and 32% are not using system or tools for alignment right now. How does that compare to when you would do classes?
Actually, I'm really surprised to see that many people not using no system at all, no tool misalignment. Yeah, because the laser alignment systems have become very commonplace out in the real world.
Sounds like it's a great opportunity for people to
So pay
expand their
attention.
skill set. Yeah.
Definitely change the way you look at how doing alignment, and so.
Okay.
Yeah, that's surprising.
Well, I'm going to give control back to you, and you can take it away.
Okay, thank you, Leah. All right. Yeah, so like she said, I've been doing this a long time. I'm not a public speaker, so forgive me if I don't act like one. I'm more of a mechanic. But I do a lot of training for PRÜFTECHNIK all over the country, so I'm used to doing training, usually in small groups, not with a big group like this. But we're gonna have a go at this. I'm sitting in my living room like everybody else these days, and we're gonna go through this deck of slides, and we're gonna talk, and hopefully you guys will pick something up. Some of these people, for some people it'll be a little bit of review, and some of it will be very simple, but we'll start from the beginning, and we'll work our way into the more complicated things. I like to show this slide first because it basically shows what we're up against. A well-aligned machinery system typically runs a heck of a lot cooler, as you can see by this heat signature. If you have a misaligned pump and motor, things heat up very quickly because things run for a long time, and you can look just by the picture, you can see that the coupling is very hot, the motor itself is super hot. So it adds to bearing life and the coupling life, and the big one for me was seal life. I came from the nuclear world where nobody likes a seal leak, and when we started using laser alignments, our seal life was greatly increased. So it was a really big deal for me to see that. But this kind of picture shows it all. The goal is to have things alignment. So we're going to start with we'll start with the definition of shaft alignment, and this is going to seem a little simple to some people, but I'm going to go through it just to kind of get you into the mode, get you into learning about using the same terms that we do. My company sells the Rotalign, and we sell Optilines and some shaft align, some other, but the top of the line model is the Rotalign. We're going to talk a lot about it today because it has a lot of options that are going to be super useful when you're out in the field. I'll start with what is the definition, what is shaft alignment, and it's very simple to understand if you just use the word axis of rotation, which is kind of just the center line of the shaft. Truly, it is the center line of the bearings that the shaft spins on. But you'll hear people say the words coupling alignment quite often, and coupling alignment is not what we're shooting for. Because the coupling itself might not necessarily represent the center line of the shaft, because it could actually run out a little bit, the shaft could be bent a little, the coupling could be in poor shape. So you would never want to align couplings without spinning the shafts and using the actual axis of rotation to get the center lines lined up, because that's the goal really. Line up the center lines of the spinning axis of rotation, right? So it's pretty important to understand shaft alignment, not coupling alignment, right? Now, we use 4 different parameters, right, to describe misalignment. And it kind of makes sense when you get a good look at it. It takes 4 parameters: vertical, angularity, and vertical offset. So that just means you're looking at it from the side, and it's the vertical difference, angularly and offset. And then horizontal angularity and horizontal offset, right? If you look at offset, offset means the distance between the rotating axis. That's super easy to understand if both the shafts are parallel, right? If you look at that picture on the left, okay, there's a distance between the two and it's an offset. Oh yeah, that's pretty simple. But now if you look over here on the right, the offset really means the axis, the offset between the 2 center lines at a given point. And that's super important to understand, because if you look at the picture, in the middle there, the difference between the 2 shaft center lines is 3 thousandths. But if you move over to the right, the difference is 6 thousandths. And if you move over to the left, it's a completely different number. It's on the other side of 4 thousandths. These things are going to become super important if you're doing things like using a spacer shaft, like there's a spacer between the coupling halves, and it makes it a really far measurement to understand where the offset actually is. Okay, so offset is really the difference between the center lines, but at a given point, right? Now we're going to talk about angularity. So the angularity means the angle between the 2 rotating axes, right? But we use the word gap to describe our angularity. And the reason we use the word gap is it's a gap difference at a working diameter. So you can see by the picture, there's a bigger gap at the top than there is at the bottom. Now, the gap number comes from back in the day when we used to use dial indicators. The dial indicators would measure the top and the bottom, and you would compare the 2 and give you the angle. There are people who use the actual angle for the results, but I find that very confusing because the angle would be a super small number. And it'll be hard for you to understand what the angle really looks like. So if you take a gap, like say at 10 inches, which is where we always leave the coupling diameter 10 inches. If you take that gap at 10 inches, you get a good understanding for what that angle really looks like, okay? So that's the reason our tool defaults to 10 inches, just because it's super easy for the mechanic to understand what the angle looks like, all right? There are reasons to change the coupling diameter to the actual coupling diameter, and it would only be if you had a target value, and we'll talk about target values later on when it gets a little more into thermal growth, right? I'm going to talk about some different types of couplings. These are all short flex couplings. We call it a short flex coupling because there's a short, small distance between the shafts, and you got to put a flexible coupling in there because obviously no 2 shafts are ever perfectly aligned. You couldn't just bolt them together. But each of these couplings gives you a different problem, so to say. So when you're doing alignment, you're performing alignments, you have all these different couplings to think about when you're performing your alignment, and some of them give all kinds of different challenges. Like for instance, that one that looks like a big black tire, there's some play in the bolt holes, all right, and it'll give you problems if you bolt it together before you're really lined up. Now, if you're performing alignment on one of these rubber tire types and you put the motor down, and the motor is like 30 thousandths low, and you bolt the motor down and you couple it up, and then you perform your alignment check and you raise the motor 30 thousandths, that rubber tire is going to not like to be offset. So you bolt it together and then you squish this rubber in the vertical direction, and it affects the way the motor runs. So it basically put a crank into the system because the shafts are trying to push against each other. So what I tell people is whenever I'm doing one of those particular couplings, I like to leave the bolts loose because there's a little play in them before the alignment is complete, and then I'll couple it up, and the machine will run much better. I ran across this many times. your vibration guy will see a 2x vibration that is typically a misalignment signature, and it has nothing to do with your alignment values. It has more to do with the coupling itself. So this particular coupling is actually best performed or aligned uncoupled, right? So you can do an uncoupled alignment. I'm gonna actually show you one later. Our tool has a pass feature, which is really awesome for doing things uncoupled. But each of these couplings has its own knack per se for performing alignments. Some of them are much better at handling offsets than others. Typically that rubber one, it can handle an angle really well. Like if you put the motor on with a severe angle, it can handle it great, but it can't handle an offset very well at all, nor can the two to the left of it. That rubber element inside wears out really quickly. So they all kind of act a little differently. They all give their little problems when you're performing the alignments. Some of those come with experience. I like to just bring it up when I'm in a class and teaching people the kind of things that you see here and there. But short flexible couplings are there to take up any misalignment between the two, and you're always going to have some. Nobody's going to have them perfect, right? So talk about short flexible couplings. The results for a short flexible coupling are given with the word gap for the angle, okay, and offset. But the location of the measurement is in the middle, right? Halfway between both coupling halves, right? So the offset is given in the middle, and the gap is given as a gap. The angle is given as a gap number, right? So short flexible couplings is the most common coupling you're going to come across. Most things have a short flexible coupling. When we'll get into spacer shafts in a minute, but I'm going to show you. This is how it used to be done with dial indicators. Okay, so you can mount dial indicators on, and you'll come up with the same results. Your offset would be given by that dial indicator on the left, and your gap number would be given by the one in the middle of the coupling there, right? So short flex couplings are given in gap and offset, but we're going to talk about the other type, most commonly used spacer is a spacer coupling, and you can see there's a huge distance between the two coupling halves. So they put these on when there's a lot of thermal growth, or there's a lot of misalignment, or a super high speed machine, because they can handle a lot more misalignment because there is a flexible element on either side of the coupling, right? But spacer couplings, they put a whole lot of problems in the thinking process. I'm going to show you for a second here. The results show up in a format that's called offset A and offset B. Okay, now offset A and offset B come from the days. There's no gap number for the angle. Okay, but offset A and offset B come from the days when we use dial indicators. Now, if you look at this system here, it's what we call the reverse dial indicator method. There's a lot of reasons to use the reverse dial indicator method. When you have a long spacer, if the motor itself has a lot of end play or thrust in it, you can't use a gap reading because you put a dial on the face and the motor shaft will slide back and forth. So we use reverse dial indicator for long spacer shafts, and it puts the measurements not in the middle, but it gives you two different measurements that are called offset A and offset B, right? But there are different ways to read spacer coupling. So you can sort of understand offset A and offset B are two different numbers, but there's no angle there. They're just plus and minus numbers. It's hard to understand what the difference. You have to, in your mind, you have to see what the B number is and the A number is. You can tell by on the bottom, if it's a plus number on the left, minus number on the right, you have a whole different set of results. The good thing is, with today's laser systems, all that comes out in a nice little picture. We used to have to graph these out on graph paper just to understand what it meant. Now, when you have the new Rotaline, you just select the results page. There's a nice exaggerated view for the misalignment. It's easy to understand. It tells you what the numbers are at the feet. So all those things, are easier to understand. Now, again, when you're in a spacer shaft, there's all these other problems that show up. Okay, if you look at the angle of the the top line, it's gets really severe the further you get away from the other coupling half. Okay, so we like to call this the line over length. Now, if you have a really long length and you're misaligned, you're angularly misaligned a little bit, your laser is going to have trouble seeing it on the other end. So there's a huge, what makes a cone when you're spinning it, and the keeping your laser on the target is really hard. So we have a single laser system so that your laser only points at the single detector. Now, if you had two lasers pointing at each other, it's super hard to get your angles to read in far apart spacer shafts, right? So our Rotoline has a pretty good sized detector, and if you put the laser on the machine that you're not moving, you have a much smaller target over there on the right, and you can handle a lot more angular gap or angle in your misalignment. And even with the new Rotoline, there's an extend function so that it goes off the screen. You can just hit extend and you can keep going. So it's a really super handy feature that adapts to any problem that kind of shows up in the middle of your alignment. That's a little bit complicated to understand these angles, but there are other ways to read the misalignment in a spacer shaft. Now look at this, you could read it in two different angle numbers. Now there's 7 ways to read results in the Rotoline. You can read it in angle A and angle B, which is, like I told you, is a little hard to understand because they're really small numbers, and again, hard to understand where the actual machine is. But then I like to show this one because gap and offset is just like we used in a short flex coupling, but what you have to do is you have to take it on one side of the coupling. Now, notice you can take it on either the right or the left, but the measurements are over on the right side of the coupling. Now, these numbers are in gap and offset, just like you did a short flex coupling. But you have to know that if you took them on the right, they would be way different than if you took them on the left. Because if you look at the line with any angle at all, it's going to be different on either side. Really important to know if you're going to be comparing these numbers to somebody's old dial indicator numbers, right? Or a target value that a manufacturer told you to put into your alignment process. Or if somebody gave you old readings from a last alignment, you're trying to compare them. So these are the kind of things you kind of really need to learn. These are the little bit harder things that a newer mechanic is going to have to understand when the results come out, right? So these are the kind of the basics for the short flex, the spacer shaft, and now we understand what misalignment really is. And after this, we're gonna get on to some of the problems and some of the other things we can get into. But I think we're gonna ask a poll question now. So if Leah, I think she has to.
Indeed. I am going to ask one more poll question for the audience. So how would you all describe your current alignment challenges? And if you're not currently doing alignment, then just select basic, that's fine. So are they basic, somewhat complicated, incredibly challenging and complicated, or are they unpredictable? So give us just a moment. And again, we really value hearing from you all. So go ahead and click whichever answer is most reflective of your current situation. And when I get to 70%, I'm going to share the results with everyone. And we are almost there. So how would you describe your current alignment challenges? Basic, somewhat complicated, incredibly challenging, or unpredictable? Okay, it looks like we are about there, so I'm going to share the results with everyone now. We have over half of the group at basic or not doing, and then we have about 30% at somewhat complicated, 10% at over the top challenging, and 6% at unpredictable. Does that about match up what you would expect, Dave?
Yeah, actually really does. I mean, I love the incredibly challenging and complicated ones, so that's part of the fun for me. So basic is like I said, normally you're going to see a lot of basic short flex couplings. and it's super easy for someone to get into just performing alignments. But as you perform these alignments, that's when the things become unpredictable. So in the middle of your job, you might be sliding your motor over and it's not going to make it, and then
Right.
your tool has to adapt to your problems. All right, so we're gonna show you why and how the RotoLine is super adaptable to any of these problems that show up, even the super incredibly challenging ones. All right, so the RotoLine was designed for these kind of things, even though it's super awesome at the basic problem, basic alignment. It really can do everything you ask of it. So
Excellent. And a reminder to the audience that you all can enter questions at any point using the questions feature on your dashboard, and we will get to as many as we can at when Dave is done presenting. All right, back to you, Dave.
Okay. I'm going to get in the fun part. We're actually going to talk about performing alignments. Okay. We got through the basics. We know that we just have 2 rotating axes. We're trying to get them lined up, right? Now we're going to perform the alignment, and I'm going to go through this couple little lists here. It says machine tagged out. I'm not going to teach you guys how to tag your machines out. Please lock them before you work on them. I think most people know that. We're going to talk a little bit. It says base okay. Now that seems pretty basic, right? If you pull a motor off and you put a new one on, take a good look at it. You're going to want to make sure it's flat. We're going to find out if it's flat because we're going to measure the soft foot, but take some care. Make sure your base is flat. I don't like to use a file because I don't like to use to put angles on them, but sometimes they look like, you know, a dog chewed them or something, so you might have to. But a stone is best to take the bumps out because those things can get you. It says shims okay. Now, maximum 4 shims. I'm going to tell you you do your best. I've heard other people say maximum 3. That's probably pretty much impossible. You're going to want to use the least amount of shims possible. I'll show you why. They become big springs. I've seen all kinds of things underneath motors. Old tin cans, you know, sheet metal from somebody's car, cut up into little pieces. You really want to buy the really good, nice stainless steel machine ground shims that'll help you with the alignment. Bent bolts and cupped washers. Bent bolts are funny because if you don't know it's bent, and while you're performing the tighten down, you're gonna see the machine move, right? So you start tightening the bolt down, and the bolt is moving the motor left and right. So you don't want to see that. The other thing is there's cupped washers. If your motor has a big old dent in it and the washer's cupped, when you're tightening it down, it's going to try to slide back to where it was. All right. Hold down bolts and jacking bolts lubricated. Sure, you want to lubricate them. Good clean bolts. Jack bolts are great. You're not going to see them everywhere, but that's life. They're awesome when they work. Pipe bracket and pipe and strain eliminated. So normally these things are taken care of during installation, and the pipe strain is normally on the pump side. Although sometimes you'll see motors with great big electrical connections that'll move the motor when you try to loosen it up. All right. Shaft's okay. So run out and bearing bear end play. Run out is something you definitely should measure, but you'll have to do it with a dial indicator. There is an XY view you can watch for some bearing end play, some lifts and things like that. But these are all basic mechanical things. This is not over the top stuff. You just want to make sure everything's straight. Our tool won't tell you if the shaft is bent, but it'll still line up the center lines of the bearings, which is great. Coupling okay, proper fit on the shaft. So if you take a coupling and the hole is too big and there's set screws in it, and you tighten up the set screws, the coupling pulls itself to one side. So you get a great big old weight imbalance, all right? Now you can still line up the center lines of the shafts, but it's still not right, right? Soft foot eliminated. Soft foot we're going to talk about, it's the enemy to the motor, and it's even more an enemy to the aligner, okay? We'll get to that. Targets and tolerances established. We're going to talk a little bit about thermal growth later, because if you're going to have to purposely misalign it to have it run at its running place where it's running, you're going to want to purposely put in the targets and the tolerances. Our tolerances are built in, which is really good, and they have to do with the speed of the machine, right? So we're going to talk about some of the problems you run across in your alignment, okay? Now, I show you these bolts because I want to know where I can get some. oftentimes when you're making a side move, you're going to see like you're sliding the motor over and you're almost to where you need to align it, and it doesn't make it because the bolts become bound up in the holes. The holes aren't big enough to let the motor move sideways. So a lot of people will take their bolts and they'll turn them down to a really small diameter so the motor will go further. I don't recommend it. As a machinist, I've done it before, but I'm not happy about it. The better thing to do is to move the other machine. And if your alignment tool can adapt to the problems, it'll say, hey, you can't move the motor. You can fix the feet, okay, and fix the feet in the motor, and it'll tell you how far to move the pump side, okay? Now, this is awesome feature because people will tell you sometimes, oh, you can't move the pump, it's got pipes on it. I can tell you now I've moved a lot of pumps. Sometimes you just need to put a little shim under the pump side because the motor can't go down anymore. It has to be done. There are some times where it has to be done. And if you can adapt to those kind of problems really quickly, like in the Rotoline, you're 10 times ahead of the game, right? So you can fix the feet, move any of the 4 feet in the system, right? We also have a move simulator to see what would work. Like you can go into the move simulator and say, hey, what would happen if I just put 10 more thousandths in? Where will it be? Or if you have a box full of shims, you only have 5s. The move simulator is awesome, really good. But if you can find out where to find some of these bolts, I'd really like to know because I think they're probably none of them will work, but it would be fun to see them. All right. Now we're going to talk about the actual moving of the machine. The hardest part in alignment is the side move, right? So you're making your machine corrections. You take the measurements. You loosen up the bolts to make your side move, and it doesn't do what you want it to do. That's when it becomes frustrating. So as soon as you loosen up the bolts, if the motor goes up, it's usually because of soft foot. So soft foot is like that table at the restaurant where you sit down at the table and it rocks back and forth, and because only 2 of the feet are hitting the ground. So that's a typical soft foot problem. There are other soft foot problems like angled feet or bent feet, and these things will really mess with your mind when you're trying to make a side move. So our tool has the real-time feedback during the measurement. So if you loosen up the feet, you're not only looking at the side move, it's going to watch the shafts go up or down. And if you see that when you're loosening your feet, you realize you definitely have a soft foot problem. So that's a super awesome feature to be able to watch both vertical move and horizontal move at the same time. It'll watch exactly where your machine is. Just know that it's never really the laser's fault. The laser just stares at the one machine to the other, and it gives you the movement that that is happening. Usually the motor itself is twisting like a pretzel, or moving while you're turning the bolts. Those bent bolts will do it, body bound bolts will do it, all kinds of things. So when you see when you loosen up the bolts, you'll definitely see both things happen, right? So it's real-time feedback during the measurement. It's awesome. Okay, I got to talk about the jack bolts. Jack bolts are great, and then there's a picture of a hammer there with an X through it. I'm going to tell you, please don't use your sledgehammer to move your motors over for a couple of reasons. Not because you don't want to put big old dents in the feet of your motor, and I'm going to tell you there are dents in motors all over the world from people moving their motors. But the hammer itself, beating on the motor to make the side move, will make the shaft move a little bit in the machine, and it'll affect your real-time live feedback. So I like to use a dead blow if there are no jack bolts. Jack bolts are the greatest. If you got them, more power to you. But they make a dead blow hammer. It's like a plastic hammer with shot inside. It works really well, and it tends not to mess anything up. So making your side move, you're going to be careful. But now we're going to talk about soft foot. So the Rotoline has a soft foot measurement tool. I guess most people do now, but it's a really super simple process. After you set up your measurements, you loosen up one bolt at a time, and the laser will tell you how far the shaft moved. All right. Now it doesn't tell you the exact number of the shim that goes under that foot. Okay, but it tells you how far the shaft moves, which is really good information. The reason we fix soft foot as an aligner is it makes the alignment really hard to do. If you loosen the feet and the shaft starts to move up and down, when you're making your side moves, you're going to have a lot of problems. The real reason to fix softfoot is so the machine isn't twisted into a pretzel when it's running. So when you twist a machine up, a lot of things can happen. The air gap between the rotor and the stator will change because it's twisted. The bearings will get pinched because there's very, very little clearance in those bearings. So when you pinch the housing, the bearings will see less lubrication, right? So the machine runs better with no softfoot. But for me, as the guy with the tools, I want to get rid of the softfoot for the alignment process, right? So our tool has a diagnose button. You can see over there on the right, it says diagnose. After you perform the softfoot, if you select the diagnose button, it'll step you through some measurement details to tell you exactly what shim will go under each foot. It's a really awesome tool. It gets you there, although sometimes it's hard to know what's going on under your foot, the foot of your motor, because they can be really bent. But getting rid of the softfoot makes the side alignment, the process go really easy. Like I said, the hardest part in alignment is the horizontal move side to side, because putting shims under typically does what you tell it to do, okay? So a lot of no-nos in softfoot, and here's one of them. I said earlier, no more than 4 shims. Now, I was on this job and we tried to perform the softfoot. Well, what happens is these shims, because they're really thick and they're bent, they work like little leaf springs. So I loose up that bolt and I'm trying to measure the softfoot. This stack of shims becomes like a spring and it pushes the motor up in the air. So you imagine when I'm trying to make my side move, as soon as I loosen that bolt, the whole housing of the motor goes up and it messes with my measurement. Very frustrating process. And for this particular job, I would have ground a really nice, perfectly flat piece of thick metal and then put smaller shims on top, okay? Notice they did use a really nice, thick, hard, flat washer. These are good things to keep in mind when you're performing your alignment, okay? It's just another picture of this guy. This one had some really thick shims. They tried to put some thicker shims in, but again, these two weren't flat. They were like little leaf springs. You want to avoid that at all costs. So try to keep the shims to a minimum and look at the paint underneath. That really affects your product, because imagine 1/1000th of an inch is a really small number. I mean, a hair is 3/1000ths, and that paint made up quite a few thousandths. And every time you tighten down, you got a different number. You want to stay away from the frustration in the alignment, right? So measuring the softfoot, correcting the softfoot, getting ready for your side move is all something that's definitely done. I like to do it first before the the alignment happens. You might want to get a little close to your final numbers, but alignment is softfoot is definitely something that's got to be done, and the tool helps you through it, right? You'll see all kinds of problems. This guy probably couldn't. The bolt probably bottomed out before it even tightened up, so we were seeing movement. Now, I'm going to talk about thermal growth and targets, okay? So thermal growth is what happens when something gets hot, right? Steel gets hot, it just gets bigger, okay? So in some of your hotter running machines, you'll purposely offset them with what's called a thermal growth or a target specification. Now, it's important to know thermal growth is, people do a lot of things to try to measure thermal growth. So a lot of people will do what they call a hot alignment. They'll run the machine. They'll get it nice and hot, right? They'll get it running. And then they'll shut the machine off and they'll throw the laser on real quick and start measuring. Now, we've even tried this in the past by taking a set of measurements and then taking another set of measurements and watching it cool down. However, you got to remember that there's no load on the machine after you shut it off. So the actual running location is somewhere different than where you think it is, all right? But thermal growth and targets, I remember when I was in the nuclear plant, we tried all different ways to measure thermal growth, but there's a way newer system for that. We're going to get into LiveTrend, which is great. I just want to explain that thermal growth and targets mean 2 different things, okay? Thermal growth is typically a number given for how far a machine grows, but it's given under the feet. So if you look at the circle on the right with the 0.04 and 0.07, Those are thermal growth numbers, and they're at the feet of the machine, okay? Now, target values are at the coupling. They both do the same thing. They're just purposeful offsets for when the machine moves to where it's running, right? A lot of turbine people like to use target values because I was a turbine guy for a while. The compressor people like to use thermal growth values. Now, thermal growth values are easier to use and understand if the numbers are both the same. Like if the machine is going to go straight up 10 thousandths, it's super easy to just put 10 as a thermal growth number in your alignment. Now, if you're using a rotoline, you typically just type these numbers in, very easy to do, and then you forget about them. And then the rotoline will purposely misalign the asset so that when it's running at full speed, it's running right where it belongs, okay? So the target values are the coupling, thermal growth numbers are at the feet. It's important not to do both, okay? And these are just for thermal growth, okay? Now, we're gonna talk about live trend, okay? So live trend is the real best way to actually measure the thermal growth value, okay? So what we do, if you look at this picture really close, the laser and the sensor, okay, are mounted on the machine itself. They're mounted right to the machine, not the shaft. And you mount to the machine, okay, and then you pick how long you want to run this measurement for, what interval, how many you might want to take it every second or every minute, and for however, it might be an hour, it might be 4 hours, and then you turn the machine on and you watch it move, okay? Now, if you get the results page, there are many different ways to look at the results. Now, if you have the thermal growth, the live trend, and you perform it, you get this nice graph, and the graph gives you coupling numbers, which would be targets. It gives you thermal growth numbers, which would be underneath the feet. It even gives you a picture of the actual location of the shaft center line. Then you have this exact location of where the machine is actually running when it's running. You can also add in parameters, like if you open a valve, or if you run at full speed, or if you run at half speed. This system will tell you exactly where your machine runs. This is really, really awesome for a machine that maybe doesn't run too great. Now, if you're having a problem with the machine, your vibration guy says, well, you didn't align that well, and you know damn well as a mechanic, you made it perfect. There's something wrong with the machine. It's probably growing. Live trend's a great feature. There are plenty of people running around doing it, and then setting up thermal growth and target values, and their machines run way better at full speed and full load or whatever, right? So we're going to talk now about the alignment modes. Okay, so the rotoline has many different alignment modes. Okay, the most common one is called the intelliSweep mode. Now, the intelliSweep mode is when you just put the laser and sensor on and you just turn the shaft. It takes a huge number of readings over the course of this rotation, okay? It gives you a live measurement quality factor. It'll even tell you if it thinks you're too shaky, all right? But the really cool part about intelliSweep is it says spurious points are automatically considered inactive, which is really amazing because if you have backlash in your coupling, now no one else can do this, but if the couplings don't rotate, if they spin, they back and forth, some of that action in the rotation, it actually messes up your measurement. Well, the intelligent measurement process takes those points and eliminates them. Or if there's a lot of vibration in your measurement, it eliminates them and it averages all these things out, and it does a really good job at looking at the quality of the actual measurement. So the rotoline has absolutely the best repeatability in the industry, because it does amazing things while you're measuring it, and you get really good repeatability in your measurement. So the intelliSweep mode is the one you're normally going to use, okay, especially with already coupled short flex, couplings. It's even long machines, and again, as you're turning it, if your laser starts to go off target, it'll stop you and let you recenter the laser. So you can do it an infinite number of times, and there really is no misalignment it can't handle, which is really good because you can have a as found reading for a really severely misaligned tool machine, whereas some of the other ones, all the other manufacturers tell you have to pre-align them so that you can get both lasers to stay on their targets, right? So I'll talk a little bit about multi-point. Okay, we have an intelliPOINT as well. So intelliPOINT measurement has intelligence built in, but multi-point is used, all right, for sleeve bearings or journal bearings, right? So if you have a motor that has a lot of play in the bearings, so sleeve bearings could typically have, 6,000 to 8,000 clearance, and while you're trying to turn it, you're affecting the location of the shaft. So you need to turn the shaft a little bit, all right, and then you stop with the shaft, stop turning it, okay, and then you stop and let it push the measure button, okay. So it's definitely necessary for sleeve bearings, okay. The other one, which is really interesting, is the pass mode. So pass mode allows you to line things up uncoupled. Now remember I talked about that one that gave us problems because it was rubber. If you just left the rubber unbolted, you can use this pass mode and you can turn one shaft and then the other, and you can get it aligned up before you even install the coupling itself, all right? So pass mode is really amazing. It's accurate. It's the coolest thing to just be able to have them pass each other. And so this shows you that you can actually just spin one and then the other, and I got a little video here showing you. It's really amazing. The beautiful thing about our system is it's smart enough to know that, it takes the measurement at the apex of this arc. Because we have intelligent readings, the repeatability is amazing, right? So that's the reason our intelliPASS works, right? So I'm going to show you a quick video here. I'm going to have to start it, I guess. All right, now I'm performing an alignment here on a machine train. I know it's a little toy, but if you look at the laser and the sensor on the right, I'm using the pass mode, and as the laser swings past the sensor, it takes the measurement. On the other one, I'm actually using the sweep mode at the same time. Now, sweep mode works fine if you stop it. You don't have to keep the movement. It's taken many, many measurements over the course of the turn. And the other one, being completely uncoupled, I'm just swinging them one past the other. This is great for a gearbox because typically a machine train would be motor, gearbox, pump, right? So you can use many different modes, right, for measurement. You can use this intelliPOINT, you can use intelliPASS, you can use intelliSweep, right? And all of them are very accurate. So this works just great in any application. A lot of times you don't have the coupling, things like that. But the other thing I want to talk about is a machine train. Now, a machine train is pretty common. Pump, motor, and a gearbox in between. Pretty common, just the three, right? Now, ours can measure up to 14 and line them all up in one picture. But the coolest feature is the fact that we can measure multiple couplings at the same time. Now, if I'm performing an alignment, now you can tell by this picture here that the laser and sensor are set up on this coupling, and these two are hollowed out. Now, I'm not in the multi-coupling mode, right? So we have a multi-coupling mode where if you select it, it will put both couplings, lasers and sensors on each coupling, and you can measure them both at the same time. Now, you measure them at the same time, which saves you a lot of time because you don't have to keep moving them back and forth. But the killer feature in being able to watch both of them is the live move. So if you've ever performed a machine train alignment, typically you start at the pump, you line the pump up to the gearbox, and then you take all your equipment off, move it over to the motor, and you put it on and you try to line the motor up to the gearbox. But when you try to move the motor over, there's not enough room in the bolt holes to get it lined up. So you take the stuff back off and you put it back on the other one and you move it back a little. We have a move simulator that helps you in this case. But if you have two sets of heads, you can watch the gearbox move in the middle and you can set it in a place where the alignment is acceptable between both machines. What a game changer. Oh, when I started using that, it was my favorite. So it's a super awesome feature to be able to measure and watch the moves of multiple couplings. Now, our tool will actually accept 6 couplings. If you have 6 sets of heads, You can measure them all at the same time and watch them move all at the same time. Now imagine if you had 7 machines and you had to line them all up, and you could just go along and put them all in the move mode and just watch them all move and just make all your side moves as you go to tighten the whole thing up. It's a game changer, really fast stuff, right? So the adaptability of our tool is amazing. It'll get you through anything that you come up with, right? There are even more features I haven't talked about. It would take too much time, but it's just a super awesome, super easy to learn touchscreen tool that I've come to love and use, for alignments. But it specifically makes the job easier for people to learn, and that's the biggest important thing, because like we said about the aging workforce, there's no longer just that one guy who can handle it, right? So that's pretty much what I wanted to talk about today. We have an question and answer session. I guess you can type in your questions, and Leah's going to help me out. We're going to try to get through as many of those as we can. I don't know how much time we have left, but if you have any questions.
Yeah, we've got time left for questions, so please do type them in. And thanks, Dave. This was really good. The first question is more or less about where should people start who are newer to alignment? So either on the I'm not doing it at all, or they're using an older system. If they want to start doing alignment with a laser system, how do they go about that?
Well, here's the thing. The great thing about the Rotalign and the Optiline is it is super easy to learn. Super easy to learn. It's a touchscreen. I'm going to say if you're going to get serious about alignment, just go right for the top of the line tool, because everything is in there and you can learn it slowly.
Okay.
We can give training. We'll come out and teach you how to use it, but it's super easy to learn. And if you're just going to perform really simple alignments, it's really easy. But as you go along, you can pick up but using a laser is great. I learned on dials, so I was the old school guy, and at first lasers were hard, but they're super easy to learn. So the best way is to dive right in and honestly, the best way is to buy the best tool, because you don't want to no, honestly, you don't want to buy the cheaper tool that doesn't do as many things. I think you'll find yourself frustrated.
Right.
So
right.
Honestly, the best tool with the best, adaptability is really the best way, because it's not hard to learn how to use.
Fair enough. Back at the slide where you were talking about how to shift and not shift your machine, and you said it was okay to use a dead blow hammer. Somebody asked if you could use a piece of brass rod to side shift.
Now, look, it's going to happen. People are going to use what they have, right? I'm an honest guy. If you have a brass rod, that's great. But the reason isn't so much that you're not going to bend the foot of the machine, which is bad. The reason you don't like to beat on it, okay, is because the shaft inside the motor wiggles a little in its bearings, and it sees that movement while you're watching the live move. Now, I'm a dial indicator guy. If I have a machine that's giving me trouble, I will get the dial indicators out and I will put them on the feet as well, and I will watch both. And if both the dials match the laser, I never have a problem. Anybody who does this is going to thank me for this in the future. So the brass bar is not the best. Dead blow is better, but jack bolts are even better than that. If you find yourself being able to pinch it over, you know what's even better? A hydraulic jack, if there's something to get to.
Oh. In general, does it take longer to align a smaller motor pump system than a larger motor pump system?
I love that question, because yes. I'm going to tell you why. It's not the size, it's how well the motor reacts when you unloosen the bolts. Now, a great big motor, okay, doesn't twist when you loosen the bolts. And typically it has to get moved with something like a hydraulic jack. So if you have a little tiny motor and you loosen all the bolts, the frame will twist, and you'll see movement on your laser and sensor that barely represent what you just did, because you might not have moved it sideways yet, but a little tiny bit of soft foot will make the numbers change in your live move. The good thing is that if you can see the live move, As soon as you loosen the feet, you know you didn't go sideways. If the up and down vertical numbers change, you know you have a software problem. That's one of the beauties of having live move. You know you have a problem. Try to fix that, and your side moves will be easier.
Nice. What about if your system is controlled by a VFD? Are there particular features and functions you're going to utilize?
Not so much for the alignment process.
Okay.
You're going to want to align it either true. Well, so we're talking about live move now. If there are thermal growth values and you see it at different speeds or things like that, you might want to know where it lives most of the time. You know what I mean? Like so just lining the tools up is just a basic, let's line these bearing center lines up so that the thing runs true. Where it runs is the next question. That's going to have to be on what type of machinery, how hot it gets, what kind of loads make it move different ways. So our tool is more of just a mechanical bearing center line alignment tool. You just want to get them true, but you want them true where it's really running. That's why live trend is an amazing feature, right?
We have an audience member who wants to know if they can use sensalign 5 and sensalign 7 both at the same time in multi-coupling mode.
Yes. In fact, and that's a good question, because you can, if you have a sensalign 7 set of heads, it unlocks the feature. If you only had sensalign 5 heads, it's an octalign and it doesn't have that feature. So if you have one set of sensalign 7 heads, you can use the sensalign 5 heads after that. You can use 5 more sets of sensalign 5 heads. So you would have one set of sensalign 7 heads, and you could use 5 more sets of sensalign 5 heads. Okay, but the intelligence features are not in the sensalign 5 heads, so they won't knock out vibration, take out backlash, or have spurious movement problems eliminated from the measurement. The sensalign 7 heads are better for that, and that's why they're way more expensive. They have intelligence built in. But yeah, answer is yes.
Okay. In a train machine, the gearbox is static and multi-coupling is performed. Does the laser have to be mounted on each side of the gearbox?
No, you can actually mount the laser anywhere, but I'm going to tell you why we mount the laser on the sensor on the machine to be moved. So the fact that the gearbox is static would mean it would be best if the laser was on if the gearbox really was truly static and you weren't going to move it. It's best to leave the laser on the machine not to be moved. Okay, it gets a little complicated, but if you draw a line from the laser over to the motor, and the motor moves on an angle, okay? If you had the laser on the motor and the motor moved on an angle, the laser would move very far at the other side. Is that hard? That's really hard to understand, I'm sure. But it has to do with the line over length that I talked about.
Yeah.
That's why we put the sensor on the movable machine, because it gives you the most range for angles, right? So the answer would be yes if the gearbox was static. Better. Now, it will measure either way. You can set it up either way, but you get the most range with the sensor on the movable machine. How's that? I hope you understood.
I think that was pretty good.
If you ever want to call me and get me to explain all that, I don't have a problem with that.
Yeah, that's a good note, folks. Take note of Dave's email here. You are very welcome to ping him directly with questions. And there actually are, Dave, I'll send you these afterwards. There are some specific questions for you about trading in old lasers for new ones and so forth.
Okay.
I'm going to get in just a couple more. Here's a general question of how often should alignment be performed?
Wow, well, a lot of people only align them when they put them in, right? A lot of people.
Yeah.
Put a motor in, you align it, right? A lot of people forget about it after that. I would say it would depend on the machine. Some people will, or the importance of the machine probably is more important. Like a once yearly alignment check, which would go along with the coupling inspection, right? Because you're going to perform an alignment check. Why not look at the coupling? You want to make sure there's grease in it if it's a grease coupling, if the elements are wearing out. So it's a good idea to go back and check alignments, kind of on a regular basis, along with checking the machine, and you could do electrical tests on your machine or on your motor. Anytime you have it shut off, it's so quick and easy to do. There's no harm in throwing the tool on and doing an alignment check, right? So depends on probably the importance of your machine or maybe how hard it works.
Yeah.
So not an easy question to answer.
No, that's totally fair. I'm going to tell everyone else who has submitted questions, thank you, and we will work with Dave to get you written answers to your questions, so hang on. And Dave, if you can forward to the next slide. There is another presentation coming up on June 3rd with your colleague, Jonathan Goff, on adaptive alignment. Dave, can you tell me briefly, what is adaptive alignment?
Well, adaptive alignment is our way of saying that the tool itself can handle anything you throw at it.
Nice.
Right? And I'll be honest with you, of all the tools I've ever used, this one can do it. So the options that are built into it, and I didn't even get to them all, allow you to make changes in the middle of your job. Like if you're having a problem with a side move, you can fix the feet. If you're having a problem with, soft foot, you can perform soft foot repair. You can do, you can do live trend. The live move is a super feature. So adaptive alignment is just the ability for the tool to actually perform anything that is needed, anything that will come up in the process of performing the alignment. That's
fantastic. Okay, so for people who want to learn more, tune in again on June 3rd. And now if you'll forward one more slide for me, when we close the webinar down, please hold on for just a minute because a survey will appear and we'd really like to get your feedback on today's presentation, as well as any suggestions you have for us on future topics. So hang on after I close the webinar and please do answer the survey for us. But that's it. So Dave, thank you very, very much. This was fantastic. Excellent learning session. Appreciate it.
Oh, you're welcome, Leah. It was a lot of fun.
Great. Well, take care, everyone. Have an excellent day and we'll see you next time. Bye for now.